Hi, this is Dr. Pello, and I am going to show you using SPSS how to calculate some reliabilities and a very simple correlation between two variables. Hopefully, you've already had a chance to go through on Qualtrics yourself and to complete a questionnaire that gives you some experience with the items that we're going to be dealing with today. So these are the questions that are in there. They're also questions that I asked in a study that I conducted back in the 1990s. And two of the measures that we're going to be looking at today, we're going to be looking at the relationship between alcohol expectancies and uh, the amount that individuals report actually having drunk or drank. And we're actually getting at heavy drinking. So, and we're doing that with respect to the past month. So think of it as your dependent variable, if you will, the variable that we're trying to predict. We'll start there. So the variable that we're predicting, it has questions such as how often in the past month did you consume alcohol? How often in the past month did you get at least somewhat buzzed? How often in the past month did you get drunk? And how often in the past month did you drink 5 or more bottles or cans of beers, glasses of wines, or drinks of distilled spirits on a single occasion? And these each go from none to once in the month, 2 times, all the way up to 7 or more times a week. So high frequency. What we're using to predict uh, heavy drinking is what's called alcohol expectancies. And alcohol expectancies actually refer to the notion that we're assessing to what extent do people expect that the consumption of alcohol is going to lead to positive benefits. And the positive benefits include things such as making me worry less, making me feel like my future seems brighter, helping me out of a depressed mood, making it easier to forget bad feelings, and so on. So we have 10 of those items that assess uh, uh, positive expectations about the effects of drinking alcohol, which we call alcohol expectancies. And what we want to do is we want to simply look at the relationship of alcohol expectancies on the whole predicting heavy drinking. And what we've done is we've constructed multiple items that get at both of these two constructs. And so what we're going to want to do is to average those items to give us a single scale score of alcohol expectancies and a single scale score of heavy drinking. To make sure that it's okay to combine those items, we want to compute what are called reliability coefficients, which we'll talk about in class. Your instructor will talk about it in class later on. But these are called Cronbach's alphas. So we're going to compute the Cronbach's alphas for each of these, make sure that they're okay. And if they are okay, then we're going to average them together. And we're going to see what the correlation is. And it's pretty simple. So here's the SPS data set that you should have. I've already opened it. This is the data view. There's always 3 windows that you can potentially be dealing with in SPSS. And one of those is the view of your data. Then when you run a procedure, you get the output, and that comes in as an output window. And then there's, if you want to write code in order to, for example, calculate averages, to calculate the mean of a set of items. There are multiple ways of doing that, but I prefer to do that in code in what's called a syntax window. You'll notice here for the file command that I can open up a new data window, a new syntax window, a new output window. We're not going to worry about scripts. I can also open an existing data window, an existing syntax window, or an existing output window. Okay, so what I want to do is to go ahead and get my reliabilities. And so I have 5 of the variables here with the participant responses. The participants are responding in rows. The variables are organized in columns. And I want to see how will those correlate with each other. And so what I'm going to do is go to Analyze and then go down here to Scale and Reliability Analysis. And I can go ahead and click on these so I can see them in terms of variable names. Or if I have variable labels, I can put variable labels. These don't have variable labels, and so the variable names just show up. And if you click on that, it actually, hold your cursor over it, it shows you the full item, as well as has the variable name at the end. I personally like to look at the variable names. I'm going to go ahead and highlight those. Take them over here as my items. I'm looking for the Cronbox Alpha. I'm going to get descriptives for the item, the scale. See what happens to my reliability if the scale, if the item is deleted off of the scale. And I also want to check out the intercorrelations among the items. So I'm going to click those 4 boxes. Then hit Continue, and then hit Paste. I didn't mean to hit Paste. And so I'm going to go ahead and go back. Reliability analysis is still all set up. And so I'm going to go ahead and say, okay. And what happens is it upshoots an output window. And it says my Cronbox Alpha is 0.944. Standardized, it's 0.945. There's usually no difference substantially between them. I'm happy to report the standardized. And so I would report this as 0.945 or 0.95 rounded. And here's the correlations between the items. By the way, 0.95 is extremely good. 0.9 and above is excellent. So this means that we have excellent reliability. Looking at the correlations between the items, you'll notice that, someone who drinks a lot in the past month has also been more often to get intoxicated in the past month, which only makes sense. You kind of have to drink in order to get intoxicated. So it makes sense that correlation would be high. All of these correlations are high. The more often people drunk 5 or more drinks per occasion, the more often they got drunk. Again, this is not rocket science. That pretty much sort of falls out that it kind of has to be that way. So all these correlations are extremely high. The fact that the correlations between the items are extremely high means that we can treat this as a single scale. And that's the reason why we're getting the nice Cronbox Alpha. Over here, if there were problems, you could look at the Cronbox Alpha if the item was deleted. And if one of these items did not correlate well with the scale, like let's say one of these was a 0.4 instead of a 0.83, it would mean that item didn't correlate with the rest of the whole scale when all these items are combined. And the Cronbox Alpha might actually be higher than our Cronbach's alpha. Now our Cronbach's alpha was a 0.944 unstandardized. And here, all of these Cronbach's alphas are slightly lower than that. That means if we delete any of the items, it hurts our alpha. Not a lot for a couple of these, but it hurts our alpha. So we don't want to delete any of them. Okay, let's do another one. I'm going to do another scale reliability analysis. I'm going to put these items back over here. I'm going to get the alcohol expectancy items, plug those over here. Same statistics are checked off. Hit OK, and it gives me a 0.932. Shows me the mean, standard deviation, the number of people I have in my sample having each of these items. Here's a correlation matrix. Correlations aren't quite as high, but they're still strong. Correlation of around 0.5 is considered strong. So all of these are kind of rounding to 0.5 to 0.6s. And so all the correlations between the items are pretty strong. So our Cronbach's alpha does really well. And let's see, it's a 0.93. Deleting any item does not increase my alpha. There's no reason to delete an item with a Cronbach's alpha that high. And so we're doing good. Okay, so this says that it's okay to correlate the items together in a single scale. Now what I'm going to do is I'm going to bring over, you can open up the syntax window that your instructor should have made available to you. And I'm going to take this off. That's what happened when I clicked the button earlier on. I clicked paste and it took the command and it wrote it onto the syntax file. But here's what you got. And here is a command in SPSS that says to construct a mean. And the way it does this is says it uses the command compute to say I'm going to construct a new variable. We can get that variable whatever name that you wanted. You could call it Ralph. You could call it Zebra. You could call it VAR 123 or VAR 1 for variable 1. You could call it just X. I usually like to keep these variable names no longer than 8 digits and to try to describe it in some way. So I basically have said here, this is for past month. I'm going to use PM for past month, and then AVG for average, and then D for drinking, keeping it to less than 8 characters. SPSS would probably let you go write out past month average drinking, but then you have this really long variable name to manipulate. It really doesn't help you out. And if you want to take it on to other programs, some other programs operate with the constraint that variable names have to be within 8. So I always like it to keep it at a maximum of 8. Then it says, okay, so I've named my variable. Now it's going to be equal to the average. That's the arithmetic mean. And so the command is mean. So I write in mean. And if you were doing this for the first time, you could actually write this all out, compute, Ralph equals the mean. And you could write this out, PM freak, then PM high, PM drunk, and PM fived. And that's all of the variables that are in that list. Here, Ralph is going to be equal to PM average D. It's going to be the same thing. I've just wrote it in a simpler way by using what's called the to convention. The to convention basically says that if the variables are organized in order, PM freak, then high, then drunk, then 5. So there's 4 variables there. All I have to do is specify the first variable, then say 2, and then go to the last. It will average everything from the first to the last. So I could have said PM freak to sex for gender here, and it would have averaged everything from here to there, whether that was appropriate to do or not. Okay, so it just makes the coding simpler. It's called the to convention, and a really handy tool to use in SPSS. Now I've also used this for my next command, compute alcohol expectancies equal the mean, going from alcohol expectancy item number 1 all the way to alcohol expectancy item number 10. Just keep in mind that they have to be ordered that way. If the order was number 1, 10, 5, 4, 6, 3, 9, 8, 7, and it ended up 7, you would have to go alcohol expectancy 1 to alcohol expectancy 7. It would get whatever's in between. So it's not paying attention to the numbering scheme in the suffix, which is something that another statistical program, SAS, does do. SAS pays attention to the number scheme in the suffix, but this is SPSS does not. It just takes them in order. Okay, so enough about that. So we highlight that, highlight the commands once they're written, go to this big green button that says to run the selection. Hit the run button, it runs it. Didn't give me any feedback. Depending upon how you have it set up, it might repeat the command. It should at least give you errors if there was errors. Apparently there was no errors. These show up over here. Here's my average for the drinking variable, and here's my average for the alcohol expectancies. So they're now in the data set. By the way, they came into the data set because in those commands that I was running, I put in the word execute. So as soon as you run these first two, the word should show up, but then it will be a bunch of dots, not actually doing the computations until you run what's called an executable command. An executable command can be any type of analysis command, a command to run a graph, a command to run a correlation, any kind of analysis, or you can simply beat the analysis command to the punch and you can write execute. And it then makes sure that those commands that you have specified have been completely run or executed, and now the numbers show up. And so we have our averages. So now what I want to do is to actually get the correlation between those. So I go to Analyze, Correlate, Bivariate, go down to the end of the data set. Here's my, I'm going to put them in the opposite direction because I just like thinking of the alcohol expectancies as my predictor and the other variable as my dependent variable. So I like the predictor to go in first. And I run that, and here's the correlation. And the correlation comes out as a strong 0.503. So it's a strong correlation between alcohol expectancies and the amount that people drink. And it's significant at p equals 0.000. In other words, it's the probability value is probably something like 0.0000324, but it's less than 0.0001. And so this shows up as 0.000, meaning that it's highly significant. You know, it's a strong effect with 413 people. You'd expect for it to be highly significant. Now, to get a pictorial representation of this, I can run a graph. You can just go ahead and specify that command here from either the output command, the syntax command, the output window, the syntax window, or the data window. It doesn't really matter. You notice you can go up here to graphs, go to legacy plots, come down here to scatter plot, hit simple scatter plot, hit define, and then go down here for my y-axis. I want past month heavy drinking. For my x-axis, I want the alcohol expectancies. And I'm not going to bother with labeling the cases. And then I'm going to hit OK. Okay, thought I did something wrong there. Apparently, and I actually went and did it a second time because I thought I did something wrong. But apparently, it was just taking a really long time to do that command. So here's how the data shows up. It's kind of a mess because there's overlapping values. So here there's probably a whole bunch of people, and here there's only a few. Now, to get an idea of our regression line, what you can do is you can double click on this graph and then go up to this right here, where if you hold your cursor over, it says add fit line at total. And I clicked it. It went with the linear line. And so it's now added the fit line to the total. I can also try and get a better, easier look at my data elements by going down here at options to bin elements and saying I want to mark this by either marker size or color intensity. And there I can now see that there's a whole bunch of people right here, and there's fewer people over here. It actually gives me a scale indicating that I probably have around 70 people here. In some places I have, only one or two rounded off at 0. But those, the size of those isn't really all that helpful. I mean, I don't think that's as nice as another way of going about doing it. And so what I prefer to do is what's called a jittered scatter plot. I've actually written syntax for you for a jittered scatter plot. So if you go over to here to back to the syntax window, notice a slightly different coloring scheme indicating the syntax window. I've written code here for basically adding a small random number. Notice here this RV, that's a random number from what's called a uniform distribution. In other words, the random numbers are kind of equally distributed between a -1 and a +1, as opposed to, say, a normal distribution. I have variable labels here for these new variables that I'm creating. I'm creating a new y and a new x. So you just write down, here's the y variable that you had. We had called it past month heavy drinking. Now it's going to be called GY. And then alcohol expectancies is now going to be called GX. And then it's going to go through this algorithm. And it's going to come out with the variable named jittery y and jitter x. It has these value labels, and it's going to give me a graph. And anyway, I'm just going to go ahead and run that command. And here it comes out, and I think that's just a lot easier and a lot to look at, a lot more informative. You can go ahead and click on that. Again, add a fit line. If you don't want the label attached, take that off, apply, and there you go. And there's your final result. And you can actually take and copy that, pull that into PowerPoint, clean it up, take it over into Word, You just copy and paste it, and you have a nice graph representing your relationship, showing that there's a whole bunch of people who don't view alcohol as having positive effects and aren't drinking much, and there's a whole cluster of those. And then you have people kind of spreading out, some that have high alcohol expectancies but aren't drinking. But uh, most of the heavier drinkers have somewhat heavier alcohol expectancies, right? My heaviest drinker does not have real low alcohol expectancies. And my heaviest drinkers all have at least somewhat high alcohol expectancies. Uh, so that kind of gives you a graphical picture of the correlation. Okay, that's it for this video. I hope you learned something, and take care.